There will be times when you are expected to know how to evaluate logarithms not written in base 10 or base e using a scientific calculator. Many calculators only know how to do base 10 or base e logarithms. In this situation, you will need to know how to use the change of base formula. First, let's review how to use a calculator to evaluate logarithms written in base 10 and base e. So when we don't see a base for our logarithms, we understand it's base 10. So this is log base 10 of 28. Now with a scientific calculator, we use the log button to easily calculate our base 10 logarithms. So here we have 1.45 rounded to the nearest hundredths place. Just as a reminder, that means that 10 raised to the power of 1.45 is about equal to 28, because the log equals the exponent. So here we have the natural log, or ln, and that really means log base e, and e is a number about equal to 2.7. So we're wondering e raised to what power equals 53? Well, we can calculate that on a scientific calculator. And we get 3.97. So the natural log of 53 is about equal to 3.97. Or in other words, e raised to the power of 3.97 is about equal to 53. Now on this third one, we have log base 5 of 34. Now notice on this scientific calculator and many other scientific calculators, we do not have a button that allows us to type in our own base. So that leaves us wondering, well, what do we do now? So that's where the change of base formula comes in. So here it is. We have our change of base formula, and it says that log base b of a is equal to log base c of a over log base c of b. Now notice that the a and the b appear on the left side, and where they appear over on the right side. So in the numerator, we have log base c of a, and then the b appears in the denominator. Now, to remember that, just notice that when we write out the log, the base is a little bit lower than the a, so the a ends up in the numerator, and the b ends up in the denominator. Now we're wondering, where did this c come from? Well, the nice thing is we get to choose whatever c we want to. So we can turn a base 17 log into a base 10 log. So choose c equals 10 to use the log button on your scientific calculator. Okay, let's evaluate some logarithms using the change of base formula. So log base 2 of 39. To evaluate that on our calculator, we can do log base 10 of 39, or the common log of 39, over the log of 2. So I used c equals 10, and when we do use base 10, we don't need to write it. We just understand that it's there. So let's calculate log of 39 divided by the log of 2. Let's go ahead and use the nearest thousandths place. A lot of times when we do this, we're not at the answer yet. So let's use 3 decimal places, 5.285. All right, so we just figured out that 2 raised to the power of 5.285 is about equal to 39. Let's try one more using base 10. So we have log base 3 of 31. That will be log base 10 of 31 divided by log base 10 of 3, or the common log of 31 divided by the common log of 3. And we get 3.126, rounded to the nearest thousandths place. So 3 raised to the power of 3.126 is about equal to 31. Now, just to emphasize that we can choose whatever base we want, let's go ahead and use base e, or the natural log, for these two. So we're trying to figure out log base 12 of 34. So that will equal the natural log of 34, or log base e of 34, over the natural log of 12. And we get 1.419. So 12 raised to the power of 1.419 is about equal to 34. Let's try the same thing one more time to figure out log base 6 of 33. So that will equal the natural log of 33 over the natural log of 6. That equals 1.951. So 6 raised to the power of 1.951 is about equal to 33. I hope these examples about using the change of base formula to evaluate logarithms have been helpful. This is Mr. Ela, signing off.